Hello, my name is Patricia Morales Bueno. I am a professor at Pontificia Universidad Católica del Perú, and I'm going to present the work Improving Scientific Practice Skills in a Virtual Chemistry Lab course, which is shared with Professor Rosario Santos Rodas. The current situation of global health emergency has revealed a series of critical aspects related to organization of society and governments, the relationship between people, environment, and education, among the most important. In this last aspect, scientific education undoubtedly assumes a truly relevant role since it is necessary to contribute to the development of abilities to assess the quality of scientific information, describe, explain, and predict natural phenomena, identify the scientific issues that determine political decisions, and assume informed positions related to various situations that involve science and technology. This concept of scientific literacy is closely related to that of scientific competence, which includes both scientific knowledge and the use made of that knowledge to identify questions, acquire new knowledge, explain scientific phenomena, and draw evidence-based conclusions on matters related to science and its social impact. That is, scientific competence implies abilities linked to knowledge, to practice of science, and the individual's attitudes towards it. The capacities related to the practice of science involve the abilities to deduce the objective of a determined scientific experience, identify the variables that can be controlled or measured in an experience, pose problems, formulate hypotheses, propose research strategies, collect and process information. In addition, it includes the skills to elaborate, communicate, and support conclusions based on scientific evidence, assume and support a position related to them, and reflect on the social impact of the advancement of science and technology. The laboratory has long been considered the natural context for science teaching. If the activities to be developed in the laboratory are designed with clear objectives and with an adequate assessment scheme, high levels of achievement can be achieved. However, in the specific case of chemistry laboratories, reports have been made that indicate that it is frequent that the goals of experimental teaching are not aligned with the results regarding the learning achieved. The organization of the laboratory session usually implies that the students follow an established procedure and record the results obtained in a format structured by the teacher. There is a greater emphasis on learning hands-on techniques and few opportunities for the development of critical thinking, analysis and discussion of results, development and integration of concepts, and development of communication skills. The changes that have been made in the way experimental chemistry is taught in the context of the health emergency have opened a series of alternatives that can help to promote the capacities that make up scientific practice and that go beyond technical skill. This study reports the results of the comparison of two groups of first-year students from a general chemistry laboratory at a Peruvian university. The comparison variable was the level of achievement in the development of abilities for scientific practice, without considering hands-on technique skills, between a virtual laboratory course and another developed in a traditional mode. The participants in this study were two cohorts of first-year students of science and engineering from a Peruvian university. They were enrolled in a general chemistry laboratory course. The traditional cohort included 39 students. The virtual cohort included 42 students. Both groups were aged between 17 and 20 years. The students were organized in permanent groups of 3 members. The design of the laboratory course considered 3 stages. Pre-laboratory stage, individual preparation stage that consisted of developing some shared activities, such as reviewing some concepts related to the work session, looking for some physical properties of the substances to be used in the laboratory, analyze a video related to the experience, as well as to do some simple calculations. Development of the experimental session. In the traditional group, the students develop the laboratory experience following general guidelines for the hands-on activities, data collection, and processing. The teacher was a facilitator during this stage and promoted the academic discussion of what was being worked on. In the virtual group, the students work with simulators available online. These resources offer the possibility for the students to intervene in the manipulation of experimental conditions and verify the result in a short time for analysis and processing. In some cases, they can visualize the phenomenon at the molecular level. The student maintains an active role throughout the process, and the teacher can monitor his work, the interaction with his group mates, the quality of the discussion and analysis through the platform used. The last stage corresponds to the report preparation. The working groups prepare their work report after the end of the laboratory session. This should be sent for review a week later. This is the rubric elaborated to assess abilities for scientific practice. It was applied during this semester in all the practical sessions. The data were analyzed using a statistical package for the social sciences, 23 software. Chi-square statistic was used to verify if there were significant differences in the achievements obtained by both groups. Figures 2 and 3 show the frequency at each level of achievement for each laboratory session of the traditional group and the virtual group respectively. It is clear the better performance of the virtual group along the lab sessions. Figure 4 shows the average achievement level for the 2 participating groups. The higher frequency in the accomplished level for the virtual group confirms the previous observation. The results of the chi-square test showed that all the cases were valid. Table 1 corresponds to level and group cross-tabulation. According to these results, it can be affirmed that there is significant evidence of association between the variables, that is, that the highest proportion of people who qualified at accomplished level can be associated with the virtual group. The results clearly show the effect of working using informatic resources, such as simulators, on the level of achievement achieved in developing skills related to scientific practice. Unlike traditional experimental work, the students of the virtual group showed greater engagement in the observation and study of the phenomenon or process studied, enriching the discussion and analysis of the data obtained, the exchange of ideas, the formulation of their own questions, and the elaboration of conclusions had greater emphasis in the work of the virtual group. Additionally, the teacher's supervision of the students' work was carried out more efficiently through the platform, providing a greater opportunity for interaction and monitoring of the dynamics followed by the students. Additionally, the work carried out in this synchronous session contributed more significantly to the preparation of the final report, whose quality was notably higher in the virtual group. The goals of science teaching in laboratories should involve skills for technical work and those that promote scientific reasoning, problem-solving, critical thinking, and scientific communication. The results obtained provide evidence to consider alternatives to achieve these objectives. The challenge for educators is to develop pedagogical designs that take advantage of both direct experimental work and the use of computer resources, seeking a coherent alignment between educational goals, the design elaborated, and the corresponding assessment system. The laboratory is still the best context for learning science, but the variety of resources that can enhance student learning achievements should not be lost sight of. Thank you very much.